Going to be a little goofy because I've got some formatting issues on the Mimeo stuff today, so I'll have to try and take care of that here a little bit later. But guys, we're in 8.4. We're talking about graphing sine and cosine functions. Now this is a pretty cool section. You guys remember when we've talked about translating graphs, left, right, up, down, vertical stretch, horizontal stretch, that kind of stuff? Okay. Some of that's going to get visited today with this. It's not going to be terrible. But it can get a little tricky when we start talking about this, okay? Question we're trying to answer today is this. What are, and I'm going to blow this up here a little bit. What are, why is this not working? There we go. What are the characteristics of graphs of the, which two functions we focused on today, kids? Sine and cosine functions. So our goal is today, we want to look at exploring characteristics of sine and cosine functions. We're going to do some stretching and shrinking of graphs of sine and cosine function. Have we talked about that before, stretching and shrinking?
Yeah.
Have we translated graphs left, right, up, and down? Yeah. So we're going to apply that to sine and cosine functions. Have we done reflecting before?
Yeah.
So we're going to look at reflecting graphs of sine and cosine functions as well. Okay? Kids, here is the deal today. Vocab. It's a little tricky. I don't want you to ruin yourself on this today, okay? But stay with me on this. The amplitude, my friends. Amplitude is just this. Kim, why is this not working today?
Having an off day.
It is having an off day.
Which then having an off week.
Okay, here we go. It really has been goofy. Okay, so amplitude is going to be a term that's pretty useful to you guys. What is going on here? It will not let me do anything today. Okay? It's angry, so I'm not going to be able to write much today. Amplitude is this. It's 1/2 the value of the difference from the maximum and the minimum value on a trig function. Guys, what's the highest value on this function?
1.
No.
What's the lowest value here?
-1.
So from 1 to -1, what's that distance?
1. 2.
It's a distance of 2, right? Now cut that 2 in half. 1, okay? So I don't know why this isn't working. I'm going to try this again. Hang on a second. Okay. Please work.
Oh.
Oh, I bet I know why it's not working.
Update.
It's very possible. Okay, I think I've got it now, kids. The amplitude, kids, when we talk about something here, the amplitude, it's kind of like the height. You guys kind of see this line right here that goes right through the middle of it?
Yeah.
You guys agree that that line is kind of in the middle, meaning that this part up here kind of mirrors this part down here, so the part that's above that line is the same as the part that's below that line, distance-wise, or they kind of are the same shape. This here is called a midline right here, okay? If you can think of amplitude as the distance above or below the midline, like this midline, how many units did the highest value go above the midline according to this drawing? 1 unit, okay? Now, for our purposes today, when we start looking at functions, amplitude is always going to be defined as the absolute value of an A term. And we'll get to that a little bit later, but you might want to write that in there, okay? And amplitude is always going to be found by taking the absolute value of what value is. Okay. Now, typically, when we have an A out in front of a function, that's kind of like a vertical stretch. And amplitude is kind of like a vertical stretch or a vertical, I'm going to put VST up here for vertical stretch or VSH right here for a vertical shrink. Amplitude is kind of your new term for what, kids? Vertical stretch and vertical shrink. If A is more than 1, what do you think? Stretch. If A is less than 1, what do you think? That'll be a vertical shrink. Very good. Okay, so good on that. All right, the second thing you're going to hear about a lot in this is what's a periodic function. A periodic function is going to be a function whose graph is a repeating function. So let me just jump into decimals real quickly and show you what I mean by that. Okay. So if I go to decimals here, friends, and I type in y is equal to the sine of x, okay, what this is saying is this. If I've started right up here, you guys, what's this value up here? Negative 3 pi over 2. And the cool thing about decimals is when you're in radians mode, what does it give you those points in terms of? Radians, okay? Take a look at your chart right here, kids. Go to your chart. Jump into the sine function. Go to sine of 0 degrees in your chart. What is that? It's 0. Okay. Go to this point right here. Go to pi over 2 radians. 1. So what this is saying at pi over 2 radians, the graph is at what? 1. Okay. How about pi radians? What's that value?
0.
0. Okay. It's just plotting the values in that table, isn't it?
Yeah.
Okay. Now let me show you what happens here. Okay. We get 3 pi over 2. What's it say on your table for the sine value?
0.
Okay. And then when I get back to 2 pi radians right here, where am I at?
0.
When I get to 2 pi radians, I've made one full revolution around the circle, right? What's going to happen to the pattern if I make another revolution around the circle?
Continue.
It's going to repeat itself, isn't it? Because isn't this pi over 2 radians? Let's think about this. That goes to 5 pi over 2 radians. But think about this, kids. If I did pi over 2, how many radians do I have to add for a full revolution again?
2.
Wouldn't that be the same as plus 4 pi over 2? Puts me at what?
5.
According to this, then, at pi over 2 and 5 pi over 2, it should start to do what? Repeat the pattern. Okay, so I started here. I went all the way up, came all the way down, and I'm back to 0. I'm going to go all the way up, all the way down, and back to 0. Okay? I am going to invent a roller coaster someday and call it the sine of x. It'll be the most thrilling ride ever.
It would just repeat and do that.
It'll be
I
repeating.
think a good roller coaster, you need to go upside down.
You do?
Yeah. Big drops, up and down.
Big drops?
Like the roster.
Okay, so the thing I want you to understand a periodic function right here. Can you guys see the parts that are like here, here, here? Whoops. Parts that are in gray right here.
Yeah.
See how they go start at 0, all the way up, all the way down, come back to 0? And then that section gets repeated over again, okay? Anything that repeats, my friends, is called a what? Any graph who repeats a function is what? Periodic function, okay? Now, you're going to see things termed this way as well. What this is called is a cycle. A cycle is the shortest repeating part of a periodic graph. So we kind of talk about this right here. Let's look at this. They've got period marked right here. It kind of starts right here at the 0, comes all the way up, wraps all the way down to its minimum point, and gets back to 0. So if you guys can kind of imagine, oh, let me get my tools here.
It's like a free house. It's just like the trigger of light. Light waves. Whoa. We'll talk about Hertz next.
How many of you guys are thinking about going into anything that would be nursing or anything like that? Okay. I'm going to guess that some of this, is there a math class? Isn't there some kind of a math class that's pretty up there for people that are going into nursing to have to take that deals with some of this? They've got to do with like heartbeat rhythms and stuff like that. And
Anatomy, physiology.
it could be beats per minute. I don't know. I'm just telling you that this is the kind of stuff you're going to see. You're going to look at patterns of stuff within the human body that happen. You're going to be looking at cyclical functions that deal with this, okay? So a period, my friends.
We learned about that in anatomy.
Did you?
Yeah.
A period, my friends, then is this. It's just simply the part right here where you would be going from, you start here, you go all the way up, come all the way down. Okay? And then isn't that the part of the graph that's just going to get repeated over and over and over again?
Yeah.
Okay, and that's called a period and a cycle, okay? So this period is how long it takes right here. This one cycle is the same thing. One period, one cycle are kind of the same thing. Kids, how many radians did it take to go from 0 to, what's it end at here? 2 pi, is that right?
Yeah.
Okay, what's the length of one cycle or one period, if you will, in this graph? 2 pi. Now we're going to talk more about this as we progress right here, but guys, there is a way to know the cycle time very easily. You want the answer to that? I've always got to look this up just to make sure things are good, because sometimes they change the variables here, so I want to see what they're going to use for a variable for you guys. Okay, your period time will always be the following. It'll always be, and I'll show you what the b value here is in a little bit, but your value is always going to be, for a cycle or a period time, your period is always going to be 2 pi divided by whatever your b value is, okay?
What's the B value?
I'll show you what the b value is in a little bit, but just for now, and there's also some core concepts that we're going to look at that deal with this as well. Okay? Kids, you're going to hear about phase shift. Phase shift. All right? It does. Okay? I should have worn my Captain Awesome shirt. I could be like a part of the phase shift, couldn't I? Yeah. I have a shirt that says Captain Awesome at
Scratch
home.
your foot against the wall. Really easy.
I don't know. Could be. Mine's got a lightning bolt on it, but it says Captain Awesome. I wear it around the house on weekends so my kids know who's in charge. You like that? I do. They're the ones in charge. Don't let them fool you. Don't let you. Huh?
Can you fly?
For about 6 feet. Yeah.
Wow.
Can't relate. Mine's only
You want to watch me fly? I'll do it right now.
Go for it.
So you gotta watch someone fly. That kid right there. You can watch her fly. She's really good at flying. Okay. I like a little high jumper over there. She's a good flyer. Okay. All right. Phase shift. Here's what this really is, kids. It's simply a horizontal shift. Okay, friends. And we're going to talk about this right here. It's basically moving the graph left and right. You remember when we had stuff in parentheses right here? We said if we were adding something in parentheses for functions in college prep all this time, like if I add something that goes to the left in parentheses, if I subtract something in parentheses, it goes what direction? To the right. Okay. This function right here, they're going to have the a value up front. You're going to see a lot of stuff in this form. A, B, and H, and K are going to be some kind of number in these examples. Okay. Guys, this says x minus what? H. This would be like, if this was x minus 6 right here, this would be like taking the sine function and shifting it to the right 6 units. So this part inside of parentheses is going to be considered some kind of a what? Horizontal shift. We're going to call horizontal shifts what now? Phase shifts, okay? And in this example right here, when they go 5 times the cosine of 1/2 of x minus 3 pi, kids, what's the a value?
5.
What would the amplitude be, my friends? 5. Okay? The b value is what? Half. Okay? So that would make that would stretch your phase shift out to 4 pi. We're going to look at that here in a little bit. Okay, but this x minus 3 pi, my friends. Guys, if I have x minus 3 pi, if I'm minusing a number in parentheses, that's like taking the whole graph and shifting it what direction?
Right.
How many units?
3 pi.
Okay, we've done that stuff before, haven't we? Okay, so don't lose sight of this. In this next one here, have you guys got everything written down? Because it's going to kind of go away at times.
Yeah.
Okay. So right here, if I look at this part right here, the horizontal shift, they tell you h is what?
3 pi.
And this would be what direction then? Would be to the right 3 pi units, wouldn't it? Okay. All right, this next one's called the midline. Friends, my midline is kind of like a line of symmetry for it. Technically, it's not a line of symmetry. Well, it could be. It could be rotational. It could be a point of symmetry. But right here, the midline, my friends. This function, first of all, do you agree this is a periodic function? Up, down, repeats the same pattern?
Yeah.
Okay. Do you guys agree that the midline then is kind of right here? So I always call the midline, say, I think the midline, the best way to think about it is it cuts your peaks and valleys in half. Your peak height is the same as your valley depth. Does that make sense to you? Mm-hmm. So where does this midline occur at on the y-axis here? So in this midline right here, this midline would happen at y equals 3. Okay?
They vacuuming? They're vacuuming.
Oh, I thought that was your projector.
No, they're vacuuming. Vac this morning.
At 9:37 in the morning.
Casual.
I thought my projector was getting ready to take flight.
Sometimes that computer back there makes
Does
scary
it?
noises. Yeah.
Your ears are a lot better than mine. I've listened to too much loud music in my life.
We had to tell Scott to skedaddle on musical night because he tried to vacuum a carpet right next to the
Oh, boy.
auditorium.
I'll bet that didn't go over
And I
very
was
well.
like, hey, it's probably not the best time to do this.
Yeah,
I don't want to get yelled at by Mr. Mitchell.
nobody does. Okay, transformations. We've talked about this. These next ones will be very simple. These are things we've talked about in the past. Transformation simply means a what?
Change.
Okay, it might be a stretch, it might be a slide, it might be a reflection. Things that you're going to worry about today, kids, are this. You're going to be worried about stretches and shrinks. Whoops. You're going to be worried about stretches and shrinks. Lordy, this is not going well today. I'm sorry, you guys. My Vimeo, for whatever reason, is not working very well.
It's angry. I don't think that works.
I think it's on its last leg here. I feel bad. Well, I don't know. Keep trying here.
I think you're the only teacher who uses these.
Really?
Yeah.
Do you guys like that I use it or not?
Yeah.
Did it turn green around the edges? No. Come on. You can do it.
I have an idea. If I just you write with an extra marker and then erase it.
I could, couldn't I?
Yeah, 'cause you could just put up the.
Problem is, I've got to record this for kids that are at home and they need to see the writing. I might just, how about this? If I'm going to keep the recording going, we might not see the writing in here. Who would let me make a photocopy of the notes to send off to my online learners today? Anybody there? Okay, Aubrey, remind me at the end of this out. I'm going to go with it, okay? It's just not wanting to work today. So to my online learners, this is going to be a little goofy. Hopefully it doesn't happen like this all the time from now on.
Oh,
Wait a minute. We've got a pulse. That sine function going up now again. Woo!
No more flatlines.
All right. We have risen from the dead.
And it doesn't work.
All right. Here we go. Transformations that we're going to worry about then are shrinks and stretches, mostly vertical shrinks and stretches.
It takes flight.
Oh
Oh no!
You guys are gonna jinx it. The tile falls off the ceiling.
We're going to work left and right, and we're going to work up and down. Holy cow. Whew. My day is accomplished. Trying to think, I did CPR on the video, came back to life.
Yeah.
What would make your day better?
What's that?
I was gonna say that.
I made my wife stop and pick some up last night. I said it was a really bad day yesterday because I didn't have any pepperoni bites. X-intercepts, you know what they are, right? It's where a graph would cross the x-axis. So how many x-intercepts are on this graph? 1, 2, 3 of them. Okay? And then the maximum value is simply the highest value. Minimum value is going to be the what? Lowest value. Okay? So kids, we've kind of talked about this already a little bit. If I am looking at basic trig values, you guys have this chart on your unit circle table that I've given you. Okay? Basic trig functions. Guys, if x is equal to negative 2 pi, what's the y value for the sine?
0.
So if I was graphing the sine function, we're going to do that down here. I would graph negative 2 pi comma what first?
0.
Then, okay, let's just kind of, again, review this. We looked at this already on decimals. I want you guys to help me with the points. So we're going to do y equals sine of x here first. Y equals sine of x here. Okay, so when we're at negative 2 pi, what's the y value? Okay, when we're at negative 3 pi over 2, what's the value? 1?
Wait, what?
So at negative 2 pi, isn't the x value
Oh.
or the y value 0?
Yeah.
What's the up there in that table? When I get to negative 3 pi over 2, what's the sine value? Is it negative 1? Or positive 1? Positive 1? Okay, and then at negative pi? And then at negative pi over 2 should be at negative 1. Is that correct? 0 back to what? You guys seeing a pattern here? Up to 1, down to 0, down to negative 1, back to 0. So what at pi over 2 you think? Back down to what? Back down to what? Back to what? Okay, now I'm going to draw this graph in here. You guys tell me when I've reached one full cycle or one full period. Okay? I'm going to start here. Go all the way up. All the way down. Tell me when I've completed one cycle.
Boom, stop.
Now. Okay, because now isn't that graph going to start repeating itself?
Yes.
Yeah.
How long is one cycle in this graph? We went from negative 2 pi to what? 0. What's the amplitude of this? What's the highest value?
One.
What's the lowest value?
Negative.
Negative 1. Okay? Distance would be 2. Guys, the amplitude is really the distance above or below the midline. How many units above or below the midline? 1 unit. Okay? How many cycles did I graph here?
2.
2 of them. And it's just going to keep repeating itself every, you said a cycle time is what? 2 pi. It's going to repeat itself every 2 pi radians. Okay?
Is it always that?
It's always that. Now, we're going to change that so when we start messing with A and B values, okay? We're going to start squishing this together or stretching it apart or vertically stretching or vertically shrinking. And I think you'll catch on to that, okay? Let's just real quickly get the cosine in there. Let's see. Oh boy, this is not going well today. Okay, let's do cosine values then. So let's start over here at, call this y equal cosine. Yeah, man. Don't play games with me. Don't be playing no game. Come on, chump. Come on.
Set it down, because that happened last time. When you set it down.
Oh.
Give this thing a little shake. No. The other thing.
It's dead for good.
Yeah.
No, it's loading.
Oh!
Don't doubt it.
All right, here we go. What are we doing, cosine of x now?
Carson, I think it's your computer, not the.
I think it is too. Right?
How old are you?
I don't know. It came out of a Ford factory. I know that though. Okay.
Oh.
All right. Help me with that part. We're going to the cosine of x now. So when I'm at negative 2 pi for x,
1.
negative 2 pi is at 1, right? Okay? Guys, if I've reached 1 already, what do you think the next one's going to be? Negative 3 pi over 2 in that chart, is it 0?
Yeah.
Do I need to even read the chart anymore, or have we kind of got the periodic function figured out?
You could keep, yeah.
I believe in us.
Okay, so where am I going to be next?
Negative.
Right?
Yep.
And then at 0 it is, okay, is this one cycle all the way up to all the way down to back to where we, didn't we start all the way up?
Yeah.
So is this one cycle time right here?
Yes.
Cosine function looks like this, okay? And then this will be 0, this will be negative 1, 0, and 1. And this is, now they look pretty similar, don't they?
Yeah.
I kind of missed there, all right? But you've got an idea. You could read the values from the unit circle for particular radian angles to know what value they are relative to 0, 1, and negative 1, okay? Now kids, here's the deal. Just so you realize that the sine and the cosine are not the same exact function, just let me show you this right now, okay? Guys, jump on your unit circle. Are you on your unit circle there? Tell me where on your unit circle. Give me a certain radian angle where the sine and the cosine are exactly the same value. Pi over 4. So check this out. The blue graph here is the cosine. Are they the same graph? No, but do they have kind of the same characteristics?
Yeah.
Where are they absolutely equal at?
That one.
Pi over 4. They were both root 2 over what? Anybody want to guess what root 2 divided by 2 is about as a decimal?
0.70.
0.707, okay? Kids, when we use decimals to help us out, because you 100% have to make sure for what we're doing in big ideas today, make sure your settings are in what mode? Radians, okay? All right, I think we're catching on to this. Let's see if we can make this a little bit more challenging. Oops, wrong one, Parson. Oh, where did my tools go now? Yeah, man. I think I can do it this way. All right, let's roll on. Let's see what we've got next. Okay, some important core concepts. Now, I know this doesn't show up the best for you guys down there. We gotta blow this up to about 200%.
Where are we going? Look, look.
Lordy.
Oh, some days you wake up in the morning, you think, should I even show up today?
That was me.
That was one of those days today.
Yeah, definitely.
Okay, kids, here we go. Can you guys read that? If you can't, look at it on your paper there, okay? A couple of core concepts that are really important. These are only characteristics of what two functions here?
I can't.
Sine and cosine. This here says the domain of each function is what? The range of each function goes from -1, less than or equal to y, less than or equal to 1. So what this means is the minimum value will always be, for this just general, and we'll change it as we start changing some of the parameters. But for now, -1 to what? +1. The amplitude of the graph of each function is 1/2 the difference. We've talked about amplitude. Each function is, what's the word? Means it repeats itself, okay? The shortest repeating portion of the graph is called A. And the horizontal length of that cycle is called the what? Okay. Each graph shown above has a period of, that was the interesting part. The x-intercepts for y equals sine of x occur at 0, pi, 2 pi, 3 pi, so on. The x-intercepts for y equals pi over 2 plus 3 pi over 2, and so on. Okay? You can see that in the graph. I'm not going to get too excited about what's over here. What I am concerned about is this, two things. Where I talked about the amplitude is going to be considered the absolute value of what, kids? A. The period is going to be considered 2 pi over what? Notice the absolute value of b here, right? So maybe one thing that I should have you add on the front side of your notes, did I just put b there or absolute value of b? I can't remember.
Absolute value of A.
Yeah, look at the period where we said 2 pi over b on front where your definitions are.
Yeah.
I don't know if I put the absolute value part down there, did I?
No.
Make sure you do that, okay? All right, so let's talk about this right here, kids. What's going on? Here, kids, this is the form I want you to understand. Okay. We're going to start looking at forms of the following. Y equals, okay, it's going to be an A value out front all the time, okay? I don't know what trig function they're going to pick. In this case, we're working with what here, kids?
Sine.
Okay, you're going to have a sine. Sometimes those will be a what? Cosine. And then there's going to be a b value right after that times what's known as x minus h plus k. This is going to be standard form of our two trig functions. Now understand this. A, b, h, and k are going to be some what?
Oh, number.
A, B, H, and K will be some number. A is always going to be out front like this right here. So guys, our job right now here is to say, all right, it says identify the what? Amplitude. And we know the amplitude is the absolute value of what value? A. All right, so check this out. What we're really after here, guys, our function is y is equal to 5 sine of x, isn't it? What is the A value there, kids?
5.
It's 5. Okay, so the amplitude in this must be what?
5.
Okay, now what this is doing, kids, is this. When I have a number out front of a function like that, if that number is more than 1, what's really happening? We talked about this a million times this year. Is there a vertical stretch, vertical shrink going on? If you're not sure, let's look at the graph. But I'll tell you right now, because this is going to go away. The amplitude will give us a vertical stretch by what scale factor?
5
By 5. Okay, and let me show you this visually. Okay, think about this. You guys have that down?
Yeah.
Because it's going to go away here in a second. You guys good there?
Would B also be vertical stretch if B was a value?
B is going to be some kind of horizontal stretch or shrink, and I'll show you what that's going to change the period. So it's either going to condense it left and right, or it's going to stretch it out. Okay, and we're going to go with that's going to happen next to us. Okay. All right, so hang tight on that. All right, so here we go, kids. So what was this? 5 sine of x that we had to graph? Is that right? Don't we already have the sine of x graphed in here?
Yep.
Okay, so let's do this. Let's go ahead and graph y equals. What the heck was that? That was pretty cool. Oh my gosh. I don't know what that was, but that looked really cool. That's gonna be my
Wait.
logo for when there's my logo for,
Your roller coaster?
yeah,
That's what you should build the
we'll call it the
thing.
sine xy. That would be so cool, wouldn't it? My friends, what was I gonna type in here? Y equals 5 sine x, is that right?
Yes.
I think functions, if you go to functions here and click under trig, it's gonna be right there. Okay, and I'll put x in there. Kids, just talk about this. The zero stayed where? Okay, vertically stretching or vertically shrinking means you're pulling points or pushing points towards the x-axis, pulling away or pushing forwards. Guys, would the zero even move if I multiply by 5?
No.
How far above was this one? 1. So what's 1 times 5?
5.
Is it 5 units up here now?
Yeah.
You see the vertical stretch there?
Yeah.
Amplitude is nothing more than a vertical stretch or a vertical shrink. And can you handle that?
Yep.
Now, if the 5 was negative, what would happen? What do you think?
It would be a shrink.
Not quite.
1/5.
You guys tell me what it would be. What's a negative clear out front do to your function?
What's the x-axis?
Let's check.
Wow.
Is that what happened?
Yeah.
Okay. So we'll talk about that negative up front. If there's a negative, still the amplitude is 5, right? Because the midline's right here, isn't it?
Yes.
The midline's right here on the x-axis. How far above is the maximum? 5, and how far below is the minimum? 5. So the amplitude is still going to be what? And just like this, if I take the absolute value of negative 5, that's still telling you an amplitude of what?
5.
Okay. All right. Well, let's talk about this next one. Okay. Guys, we're looking at identify the amplitude and what? Period of 3 cosine. Ooh, we got a value in front of x right here. The 3 is like an a value. The 3 is like an a value. So what's the amplitude have to be, kids? Your amplitude is going to equal 3. Okay, the new one right here is then graph it. We'll graph it in decimals here, but they also want to know what else, kids? The period. I always write this. I'm sorry, I've got that wrong. I write this as PD all the time, all right, for period. Is that okay?
Yeah.
Okay. What did we say our definition of period was? Or our formula. Maybe that's a better way of saying it.
2 times b.
Okay, we want that b to be the absolute value of b. Okay, so 2 pi divided by the absolute value of, what is the b value right in front of x here, kids? Okay. Guys, what are the pi values going to do to each other in this? So what's the new period going to be? So instead of a cycle happening every 2 pi radians, that cycle's going to shorten up to every 2 radians, isn't it? Let me show you what's going on here. Okay. So, do you guys have that down right there? Ooh, what is this? Markup. Can I pin that to the taskbar? Oh, that's so cool.
Did it do it?
Did it stay?
I think you got too much stuff down there.
I do. Oh, is that it?
Yep.
Nice.
Yeah, you need a new computer. That thing is slow.
Okay, let's talk, kids. We were dealing, was that a cosine function, friends?
Yes.
Okay, so here's your original function, cosine of x. We wanted 3 cosine of x, right? Okay, did that stretch it first? Now, 2 pi is approximately 6.28 radians. We said 2 pi radians went down to what?
2.
Okay, so is this graph going to condense or is it going to stretch out? Okay, watch what happens when I throw in then 3 times what? And when you're putting it in decimals like this, you got to put Did that compress that for us?
That looks insane.
It does. But watch this right here, kids. I want to show you this.
That's very hard.
Oh, where did I set that?
Oh.
Okay, do you agree that maybe, I'm gonna start at the highest point here at 0, is that okay? 0, 3, it comes all the way down, comes all the way back up. Isn't that one cycle time right here?
Yeah.
How much distance horizontally is covered now?
2.
Okay, whereas originally, if I started at, I don't know if I start on this graph right here, if I start at 0 and I go all the way to here, isn't that changed 2 pi units on the x? You understand what's happening here then? Okay? A is like a vertical stretch, the B value is like a horizontal stretch or a horizontal shrink. Are you cool with that?
Yeah.
Alrighty. Well, oh no, this is interrupted. Had I said that already? 314 times? Thought so. Okay, here we go. Let's get into the good part. Already done that, we've already done that. Quick core concept. So guys, graphing y is equal to, we know what a and b do, right?
Yep.
Okay, the h is just going to be a left or right movement. Okay, what do you think k is going to be? Up or down. So this is either vertical stretch or vertical shrink, horizontal stretch or horizontal shrink. This is either left or right, and this is going to be up or down for the k value. Okay. Now, guys, they give you some steps to do this, to graphing stuff, and that's what we're going to focus on here in these last 10 minutes. To graph this, y equals a times sine of bx minus h plus k, or the cosine part. Follow these steps. First of all, it says identify what, kids? Do we know how to do that? Identify the, do we know that?
Yeah.
Can we figure out a horizontal shift? And can we figure out a vertical shift? Okay, draw in a horizontal line. This is called your what? I'll show you how to do that. Right now the midline's right at which axis every time? We have just the basic function or the parent function in there.
At 0.
It's right at 0. So this plus k is going to move everything either up k or down k. What do you think your midline's going to be? Whatever that value is, okay? And then they say graph the line y equals what here? Okay, so I want you guys to maybe highlight that. That's going to be an important one. This will be an important one. You always want to put your midline in there. All right, I'm just going to let you read through these. We'll get to it, okay? And step 3 says to do what?
Find 5 key points.
Find key points translating y equals a sine bx or y equals a cosine bx, horizontally h units and vertically k units. Draw the graph through the 5 translated points. Once you've got 5 points in there, guys, you pretty much have one whole cycle in here. Okay, so let's just talk about this first one right here. Okay? So here's some things we can do with this. I think I'm going to get through example 3 and probably stop there. Is that okay today? Things did not go the way I wanted them to, and I certainly apologize. But I think you'll have a grasp on quite a bit here today. Please work. What's the amplitude in this example, kids?
3.
All right. What is the period? Okay, how'd you get pi?
2 pi over
2 pi divided by what here? The b value is 2. Okay, so it has to be what? So the original parent function, it has a cycle of 2 pi radians. We are now going to complete a whole cycle in how many radians, kids? Pi radians. Does that mean my graph is going to stretch out, or is it going to be condensed for each period? It's going to be compressed there, isn't it? Okay. How about the k value in this? What's the plus value on the end?
5.
Your midline is at what? Okay, just to make a sketch of this. Okay, just maybe make a. Okay, let's talk about this. What function are we working with, sine or cosine?
Sine.
Okay. The sine function. I'm going to draw over here on the board. Sine function starts out like this. The sine function starts at 0, 0, 0. You always want to start at 0 if you can. Okay? If you would look at those 5 values that we plotted for the original sine function, it started at 0, 0. It went up here to 1. It went down here to, hang on a second. At pi, it went back to 0. At 3 pi over 2, it went to negative 1. And at 2 pi, it went to what? 2 pi, it went to 0. Okay, my friends, here's the original parent function right here. Oh, my Lord.
Oh, so. Okay.
Okay, so first of all, what's going to happen to this in the graph? Talk about the A part first.
Stretch.
Give me a vertical stretch. Is that by how many units? 3. So anytime you guys agree the maximum and minimum on this is at, oh, I screwed that up too. Where's our midline have to be? 5. We got to take everything and translate it up how many units? 5 units. So there should be a line up here at y equals 5. Right? Okay, so if I take this point right here, 0, 0, and translate it up 5 units, where's it going to end? 0, 5. So this 0, 0 is going to move up to 0, 5, isn't it? Okay, now this is where things get kind of crazy. What's the amplitude on the original function? 3. Okay? And so this is going to go 3 units above and 3 units below, right?
Yeah.
Now I'm just going to make the same cycle on it. So I'm just going to make a sketch. It looks like the same cycle, but I'm going to stretch it a little bit because it goes up by 3 and then we'll put our values in here, okay? Do you guys agree that that's one cycle on there? Do you get why we moved it up 5 units first?
Yes.
Okay, now let's talk here, kids. I always pick on the zeros a lot. How many zeros showed up here?
3.
Okay. What was the length of one cycle time according to what we have there? Okay, so going from 0, 0 to here, what value should this be then? Right down here, this should be at pi radians now, right? Would you agree with that? Because our cycle time shortened from 2 pi radians to what? So to go horizontally through this cycle,
Oh.
that's going to have a horizontal change of what? Pi units, right? Okay, and I'll show you this on decimals here before we leave. Guys, if this is pi and this is 0, what does this have to coordinate to then?
And that would be pi over 2.
Okay, now we got a minimum and a maximum here somehow that we need to figure out, right?
Yeah.
Guys, the maximum here, what's the amplitude again?
3.
So 3 above 5 would put you up here at something comma 8, wouldn't it? What is that something right here in the middle of pi over 2 and 0?
What?
What's half of a half?
Pi over 4.
Oh.
Pi over, yes, pi over 4, right? You think about this, isn't this 1 pi over 4?
Yeah.
Wouldn't this be the same as 2 pi over 4 right here?
Yeah.
Or pi over 2 is the same as, what do you think this one is?
3 pi over 4.
I think it's a good idea to make the sketches because then, once you've got the sketch, you can kind of figure out where these points is. This point up here must be pi over 4 comma what, kids? How many units above 5?
3.
So 8, right? How many units below 5 over here? So this will be the point 3 pi over 4 comma, what's 3 from 5? 2, isn't it? Okay, I want to check these. I want to check these here real quickly. As long as you've got that sketch down, I'm going to show you the graph here quickly, and then I'm going to shut the recording down because this is the worst recording day I've ever had, I think. I appreciate you guys being patient with me today. You guys are the best. Okay, so what was the original function? Sine function, is that right?
Yeah. 3.
Okay, so we've got y equals
3.
3
Sine.
sine
Do that
2x
in parentheses. And then plus 5.
Quick question here. We were looking at some certain points here. I was looking at 0, 5. Were we on the right point?
Yeah.
How about this one? Pi over 4, 8. Were we good?
Yeah.
Pi over 2, 0 again?
Yep.
Reminder that there is NHS induction happening during wind time in the auditorium.
In the
NHS students being inducted, or NHS inductees, make sure you go for practice during wind time in the aud today.
What do you guys think? Try to take a look at it. We'll pick this up again on Monday.